Hello and welcome back. In this video, we're going to derive the derivative formulas for the hyperbolic sine and cosine. And to do so, we're going to use their exponential definitions that we've seen already in this section. So for starters, let's take a look at the sinh function. Take a look at the derivative of the hyperbolic sine of x. By definition, that is the derivative of the e to the x minus e to the negative x divided by 2. And we know that this is the same thing as 1/2 of the derivative of just the difference of those two exponential functions. And we know that the derivative of e to the x is just itself. And then we're going to have the derivative of e to the negative x being itself times a -1 by the chain rule, which simplifies down to just 1/2 of e to the x plus e to the negative x, which is the same thing as our hyperbolic cosine definition. Now let's repeat the process all over again for the hyperbolic cosine. So we're going to be looking at d dx of the hyperbolic cosine of x. By definition, this is d dx of e to the x plus e to the negative x divided by 2. And just like before, that 1/2 is going to carry along. And then we're going to have just the sum of the two exponentials that we take the derivative of. So that's going to be 1/2. Derivative of e dx is itself. And then we're going to have the derivative of e to the negative x being itself again times a -1 by the chain rule, which turns into 1/2 e to the x minus e to the negative x, which we should all recognize now as the hyperbolic sine function. So we have shown through a simple derivative calculation that the derivative of sinh is positive cosh, and the derivative of cosh is positive sinh. So going back up here, we have the hyperbolic cosine for the first derivative and the hyperbolic sine for this other derivative. You will notice that this contrasts greatly with the cosine and sine functions because the derivative of sine is positive cosine, whereas the derivative of cosine is negative sine. But we don't see such a sign switch with the hyperbolic functions. They actually preserved the positivity of the original. So a little bit different than our trig functions, but again, that's going to be expected with hyperbolics. They're not exactly the same, otherwise we won't be talking about them. So again, nice formulas for derivatives.